Hi, this is regarding Engineering 955 presentation assessment file, and my name is Binsu Abraham Kurian. I am here to present the research topic regarding selection of a suitable welding procedure for joining a ferritic steel and an austenitic steel, and to determine the factors that are affecting the creep rupture life of the dissimilar weld joints. So, dissimilar weld joints are gaining wide acceptance in several industries nowadays due to its unique characteristic properties to withstand the different service conditions in these industries. The dissimilar weld joints possess the characteristic properties of the base metals from which it is produced. So, besides this, a suitable welding procedure adopted for joining these dissimilar steels reduces the can enhance the creep rupture properties of these weld joints. Commonly used dissimilar materials in this process are ferritic steel and austenitic stainless steels. The ferritic steel possesses good corrosion resistance, while the austenitic stainless steel possesses high oxidation resistance and are compatible with materials like sodium, which is being used as a liquid lubricant in certain fast breeder reactors in power generating industries. Numerous studies were also conducted to study the to evaluate the properties of dissimilar weld joints formed by ferritic and austenitic stainless steels. Several researchers conducted experiments on joining ferritic steel using different welding techniques. One such experiment was the joining of ferritic steel using activated tungsten inert gas welding process, where it produced weld joints with no cracks and good toughness. However, this welding process was not used in industrial applications. Other experiments employed use of filler materials that can be used for joining austenitic stainless steel with other dissimilar metals. These filler materials used in joining the dissimilar materials imparted good thermal stability, high tensile strength, and toughness. The commonly used filler materials were ER2209 and Inconel 617. Further, submerged arc welding process were also conducted to produce dissimilar weld joints at various heat inputs. However, the dissimilar weld joints exposed to longer duration of heat treatments resulted in soft zone formation, which is associated with carbon migration. Another experiment employed the use of a buttering layer over the ferritic steel, which would reduce the formation of soft zones in these ferritic steels. The weld joints thus developed would also reduce the residual stresses developed within the weld joints. Here the figure shows a buttering layer that is being coated over the ferritic steel, and then this is welded to the austenitic stainless steel. Besides the application of dissimilar weld joints in several industries, several failures were also associated with these weld joints. The main factors that attributed to the failure of dissimilar weld joints were mainly due to the mismatch in the coefficient of thermal expansion between the base metals, the creep defects influenced by post-weld heat treatment, and residual stresses. So, in order to study the creep defects influenced by the post-weld heat treatment, an experiment was conducted using shield method arc welding process, where a ferritic steel was joined with an alloy 800. So here the weld joint developed low creep rupture strength. And the failure location, it was also observed that the failure location shifted from ferritic base metal to the intercritical heat affected zone of these metals. So all these studies overall has analyzed the behavior of creep failures in dissimilar weld joints and the factors causing failures. However, no studies were conducted to determine the factors affecting the creep rupture strength of dissimilar weld joints were undertaken. So these factors include stress levels or loading conditions, weld bend size, material characteristics, and so on. So the relevance of the research topic was that to find out the factors that are affecting the creep rupture life of dissimilar weld joints, and what is a suitable welding procedure that can be adopted to join these dissimilar weld joints, which can enhance the creep life of weld joints so formed. So this has led to the developing a new research design. So here we proposed a new research design which incorporated materials like 2.25 chromium 1 molybdenum ferritic steel and AISI 310 austenitic stainless steel. So these two dissimilar steels were joined using friction welding process under different welding parameters. Here, a transition metal joint was also used between the ferritic and austenitic stainless steel, and the interlayers were welded layer by layer over the ferritic steel and then welded to the austenitic steel. So here the figure shows the interlayers of uh, uh, transition metal joints used between the ferritic and austenitic steel. So after the welding process, the weld joints so formed were then subjected to post-weld heat treatment at a temperature of 923 Kelvin. Followed by the post-weld heat treatment, creep rupture tests were also carried out at different stress levels of 160 megapascal, 180 megapascal, 210 and 220 megapascal. So at different stress levels, the creep test conducted resulted in creep rupture data, which was recorded using a Mongman Grand relationship. Further, the localized strain concentration was also measured. So here, a transition, it was observed, a transition in the failure location was observed at various stress levels. So these shift in the failure location enabled to determine the creep rupture strength associated with these weld joints. Further, the use of transition metal joints or buttering layer between the ferritic and austenitic stainless steel minimize the residual stresses and enhance the creep rupture strength in these weld joints. This figure shows the cracks that have been developed across the failure locations in these weld joints. So finally, the factors affecting the creep rupture strength of these weld joints were determined by conducting this experiment. The advantages of this process is that employing a friction welding process promoted gradual change in the coefficient of thermal expansion, which thereby reduces the failures in dissimilar weld joints. Use of a buttering layer also reduced the stress gradients developed across the weld joints and imparted good creep rupture strength to the weld joints. However, due to post-weld heat treatment for a prolonged temperature for a prolonged period, the dilution effect in ferritic base metal cannot be eliminated, and which would further result in soft zone formation. This is one of the limitations of this process. So hence, it is recommended to use a friction welding process to join the dissimilar steels of ferritic and austenitic stainless steel, which would enhance the creep rupture strength in these weld joints. And also, the factors affecting the creep rupture strength can be determined by carrying out the creep test at different stress levels. The use of transition metal joints used in this process also reduce the stress gradients developed across these weld joints. Thank you.